Yes, good morning, everybody. My name is Dr. Ghulum Bakari.
Good morning, sir.
And I would like to welcome you to this GIS Day 2024. We will keep the tradition of running a video of Jack Dangermond to start the show. It's just a 1-minute video. Can we go ahead and do that, please?
Hello, my name is Jack Dangermond, and I want to invite all of you to join me and my colleagues in the 25th annual GIS Day celebration that's coming up. Look, 25 years ago, inspired in part by Ralph Nader and another group of people, we started this celebration event. And the whole purpose was to highlight the great work that GIS professionals are doing around the world. It was about having an open house, sharing with other people in your organization, sharing with your community, even sharing with kids in school, the power of geography and geographic thinking, and of course, GIS. And of course, the work that you do. So this is going to be a wonderful event. Help me celebrate this, and let's help educate the world to the transformational power that all of you are up to in making a difference with maps and spatial thinking. I'll be looking for your participation. See you shortly.
Again, I welcome you all for this GIS Day 2024. And I also would like to share with everybody and congratulate us and Bahrain leadership, government, and people, nationals and expats on our upcoming National Day. And we had prepared a video to share, but I don't think we have it, but
I can play it.
You can play it? Okay.
لو سمحت عاد تساعدني ارفع العلم؟
تبي ارفع لك؟
اي تعال.
يلا.
اوكي.
في العالي ولا انطفى نورك، انتي حلمنا وانتي سندنا وانتي املنا يا وعدنا الغالي، تاجن على راسي يا بحرين. بحريني اسم النبع بالشوق، هذا صوتي وهذه مواويلي وهذه امجادي وهذا تاريخي يا غالية في القلب والعين. صوتك ضوى نجمة يلاقيني لين أظلمت دنيا وسنيني، يا أول الأفراح في عيني لما تفرح وياك تكفيني. بحرين طول العمر مكانك يا الله.
I'd like now to start with a couple of things about Micro Center. We are celebrating this year our 40th. It's okay? Yeah. We are celebrating our 40th anniversary this year. And we actually started in 1983, but our CR was formally given on February 28, 1984. And because of the name that has to be Arabic, we wanted Micro Center, so they asked us to translate the name to Arabic, and we had to come up with something, so we said Markaz al-Ajhiza al-Saghira, so that the translation will be Micro Center. And until 2010, that was our official name in the CR. When we changed it to WLL Company, we changed it officially to Micro Center in both Arabic and English. Now, we started when the microcomputers were just coming in, and this is the first computer that I had when I was doing my master's in 1982 in the US, TRS-80 color computer, and it had basic programming and it has no storage at all. You had to connect it to a tape recorder to record, save things. And you had to put cartridges in for various games or various programs. The next actual computer that we used in Micro Center was an Apple computer or Apple compatible computer. And we used the CPM operating system, and it was an 8-bit processor. Following that, IBM entered into the fray, and IBM PCs came, and it was much more powerful. 16-bit processors, PC-DOS operating system came in. It was floppy disks at the time. Back. Floppy disks at the time, and it was 360 KB storage capacity per floppy. You can imagine this is 1/3 of a megabyte. We're not talking gigabytes at all at this time. Hard disk storage was 10 MB, 20 MB, something like that, and it was very expensive to buy. And the operating system was Microsoft DOS. A few things about Micro Center, I would say. When we started, we were the first microcomputer based. We developed actually the first microcomputer based inventory and stock control, which was integrated with general ledger and POS machines in one system. Before that, everybody was using mini computers and some of them mainframes for this kind of applications. The original development was done in DOS using DBase 2 and DBase 3 Plus and Clipper. And of course, many of you of the younger generation don't know any of these softwares. Later on, Windows came into the picture and with Microsoft Windows, and we switched on, or actually redeveloped in Delphi, starting from Delphi 2 up to the latest versions of Delphi, which was 10, and we were using Oracle database at the time for security because the customers has grown. Then we had to redevelop this completely on Oracle, using Oracle JDeveloper with Java platform and Oracle ADF mobile technology. We then had to go into remarketing this as a MCAE biz, and it's gone through so many releases. Currently, it is release 20, which was in 2021 onwards. We have about 100 customers using this, medium-sized companies. Currently, we are redeveloping this again, totally using microservices architecture with React and Node.js. This development is in progress. I should say that in Micro Center we have about 30 developers in-house, and we have been developing everything in-house since we started. The organization structure is, we've grown from this ERP, which is on that side here, to this organization, which you see now with over 110 strength. I will not talk much about this, but this is why now we are talking about Micro Center Group. Okay, let's go. I would like to now introduce the agenda for today. We have 5 speakers after this, and I would like to thank those companies and organizations who have actually taken the time to be present with us and present with us and share with us your or their knowledge. Let's go. You don't have the.
That's it.
Huh?
My slide is like that. This is the horse slide.
No, this one can continue.
Yeah.
Okay. The first speaker will be, actually, I will not go into the details of the speakers. I would like to thank Esri Global in Dubai office to share with us the first presentation. And next will be the National Space Science Agency of Bahrain. I would like to thank them for their presentation. And third will be in the IGA, Information and E-Government Authorities in Bahrain. And we have quite a history with IGA, which I would like to share a little bit of with you. We started with IGA when the name was in the 1990s, I think. It was CSO, Central Statistical Organization. And they were pioneers actually in bringing technology into Bahrain. They developed the address system, the modern address system for Bahrain, and all the mapping that you see all over the place now was started with CSO enforcing digital mapping through what was then microstation DGN files and intergraph workstations and so on throughout the thing. And we started with CSO after becoming Esri distributor, and our first actual development, GIS development, was with them to develop to link the mapping system which was existing to the address system as a geodatabase. It wasn't a geodatabase then, it was an Oracle database. And that was our first project with CSO. We then moved into the name change, which was CIO, and we were dealing with Allah yarhamah, Dr. Muhammad Al-Amir at the time. And later on, it was again merged with the E-Government Authority of Bahrain, and the renaming was also done as IGA, which is Information and E-Government Authority, which is currently what it is right now. Mostly, of course, we are dealing with the GIS Directorate in IGA, and we have been dealing with many of the directors of CSO, CIO, and IGA. Currently, I'm thankful to Dr. Sheikh May Al Khalifa for being at the forefront of all of our activities in GIS, and I would like to thank her and her team for that. The next organization which I would like to mention and thank is Earth Eye Space for sharing this GIS Day with us. And of course, the last speaker will be our speaker, Mr. Aduri Srinivas, who's the strategic projects head in Micro Center. And I would like now to introduce our latest addition to our GIS professional team, Mr. Mahesh Rajan. He's joined us how many months?
3 months.
Yeah, 3 months ago as a business development manager at Micro Center, and he is a RGIS certified professional. He has 25 years experience in IT and GIS, and he has worked with large corporates in various roles as a consultant, a GIS consultant, and he has been heading many business units with companies in the UAE, India, and currently now in Bahrain. He will take over now and introduce our speakers, and one by one, and of course, handle any questions you may have at the end of each speech. I would like, from my side, to thank you once again for being here, and have a wonderful GIS Day, and hopefully a very fruitful one too. Thank you very much from my side.
Thank you.
Mr. Mahesh.
Yeah, thank you, sir. Hi, hello, Bahrain. Not only Bahrain, Dubai, Sydney, and Singapore. Let me just, that was quite a wonderful introduction about Micro Center, the company of technology, house of technology, the house of the first. So we will be introducing, the first platform, which is in the first time in the Middle East, that we are coming to later in the whole discussion. So going ahead with the agenda for today, I would actually immediately start off with Esri. I think Esri needs no introduction. We will start with Mohib. We affectionately call Mohibullah Sahak as Mohib, and let's go ahead with it. Mohib is actually the business development manager for Middle East and Central Asia. He would be covering one of the most important topics here, which is actually about a full licensing policy change with Esri. The topic is ArcGIS user type updates. Over to you. Let me just,
Okay, Mahesh, thank you. Let me start sharing from my side.
yes, please.
Are you able to see my screen, everyone?
Yes, Mr. Mahib.
Okay. I hope it's not the wrong presenter view or is it the right one you are seeing?
Yes.
Okay, thank you very much. So good morning, everyone. First of all, happy GIS Day to all of you. Thank you for the opportunity to be part of the 2024 GIS Day event in the Kingdom of Bahrain. So my name is Mohibullah Sahak. I'm a business development manager for Middle East, North Africa, and Central Asia based in Esri, Dubai office. I work with our customers, distributors, and partners to be successful with our technology. And today I would like to talk to you about how Esri can help you take full advantage of our updated user types. To get started, I would like to take a few minutes to explain and clarify some key concepts, starting with the basic question, what is ArcGIS? Well, ArcGIS is an enterprise-ready, comprehensive geospatial technology platform upon which systems are designed, implemented, and operated with access granted and licensed through user types. The term system is used to describe a set or subset of ArcGIS capabilities, apps, and content that are designed to support customer workflows, business requirements, and deployment preferences. Systems are scalable and support individuals, teams, or entire organizations. And based on our customers' preference, they can be flexibly deployed using software as a service, SaaS, platform as a service PaaS, or self-hosted in virtually any environment, whether public cloud, private cloud, or traditional on-premise infrastructure. Last but not least, systems should be packaged with the right level of support and services from Esri or its partners to ensure customer success. First, let's start with a reminder about what's changed with our updated user types. We designed ArcGIS user types to match the way your team works. User types give each individual in your organization a secure identity that they can use to access ArcGIS. They are each assigned a specific user type level based on their role and responsibilities. Their user type level determines their level of access to ArcGIS capabilities and apps. This gives you the flexibility to deliver the right level of access to each user in your organization. A user type typically includes three things. First, a user type includes an identity that provides secure access to ArcGIS systems. Second, it includes several capabilities from viewing, editing, creating, all the way to administering the ArcGIS system. Third, it includes apps and contents to support organizations be successful in their work. In 2024, we evolved the user type lineup to deliver even more capabilities and make it easier to match user types to the roles in your organization. Let's talk through some of the most important changes. The editor user type has now become the contributor user type. Since people with this role are often responsible for reviewing and contributing to projects, not just editing features. The creator user type is the most popular entry point to create maps, apps, and information products that you use to run your business. For years, we have empowered creators to do this work in the browser and on their mobile device. We are now giving them the ability to do this work on the desktop as well through RGS Pro Basic. And we recognize that our advanced professional tools are powerful even for users that don't consider themselves GIS professionals. So we renamed our two most advanced user types to Professional and Professional Plus. The updates we have made to the user types are designed to provide you with a few key benefits. First, they make it easier to align RGS capabilities to team roles. You can easily decide what licensing your users need and manage their privileges based on their role. Second, they help connect people across your organization. Everyone has an identity in RGS that they can use to log in and share content with other users. Third, they streamline user type administration. We have made the choice of user type simply by reducing the number of user type options and adding even more apps and capabilities into each one of them. And finally, they help you scale as organizational needs grow. You can easily add more user types to support additional teams and departments as needed. And because our user type levels deliver a progressive growth in capabilities, users can upgrade to a higher level when they need access to even more of RGS. Now I would like to talk to you about how Esri can help position you for greater success with ArcGIS. To do that, I would like to focus on helping you develop a plan for migrating from ArcGIS desktop to modern ArcGIS technology. First, let's start with a reminder about what's changing with ArcGIS desktop and why we are encouraging customers to migrate. When we first released ArcGIS Desktop, the primary way we delivered GIS capabilities to users was through desktop software. Since then, technology has transformed. And as mentioned earlier, ArcGIS has evolved to become the world's most comprehensive geospatial platform. Users access this platform through user types that let them apply GIS capabilities across desktop, web, and mobile environments. User types are enabling organizations to evolve the way they use GIS. Today, they are implementing systems that apply RGS capabilities, apps, and content throughout the organization to support specific business workflows. At the same time, Esri has also introduced the latest generation of desktop GIS, RGS Pro. RGS Pro is the successor to ArcMap. It's a modern desktop GIS application that builds on the tools in ArcMap, delivers new capabilities that aren't available in ArcMap, and integrates with the stack of software and capabilities that users can access through RGS user types. RGS Pro is now Esri's flagship desktop application for mapping and analysis. Since introducing RGS user types in RGS Pro, we have continued to support RGS Desktop and ArcMap. However, RGS Desktop is nearing the end of its life cycle. It entered mature support on 1st March 2024, which means the software will no longer receive updates. Licenses are no longer available to quote as of 1st July 2024. This means you can no longer buy new licenses. It will be retired on 1st March 2026. Once RGS Desktop is retired, you will still have access to the software you access through a perpetual license. However, Esri will no longer provide maintenance and technical support for ArcGIS Desktop after it's retired. This means it's time to start planning your migration from ArcGIS Desktop so you can continue to access the latest enhancements from Esri and be successful with ArcGIS for the long run. Now let's talk about how we are migrating users who accessed ArcGIS Desktop through a subscription. The last day that you are able to renew an ArcGIS Desktop subscription was 1st July 2024. When your subscription licenses are up for renewal, you will be automatically quoted an ArcGIS user type that's equivalent to the ArcGIS Desktop level you purchased through your subscription. You will also be quoted add-on licensing for any extensions that you had previously purchased for ArcGIS Desktop. This default quote is designed to match the capabilities you previously licensed through your subscription. We will not automatically renew your subscriptions as user type licenses without your consent. So you will have a chance to opt out and choose a different combination of user types if you wish. However, keep in mind that once your subscription expires, you will no longer have access to any ArcGIS Desktop software you previously accessed through a subscription. Those users should migrate to user types to access the software they need. We know many ArcGIS Desktop users access their software through perpetual licenses. We are offering multiple migration pathways for these users so they can pick the right combination of licensing to meet their needs. If you are current on ArcGIS Desktop maintenance, you have got a couple of options for when and how to migrate from a perpetual license. First, from now until 1st March 2026, you can take advantage of Esri's ArcGIS Desktop early migration offer. Now, what is this offer? This offer allows you to get early access to user types for each of your ArcGIS Desktop licenses at no additional cost during your entire current maintenance terms. The second option will start to kick in when maintenance comes up for renewal after 1st December 2025. Instead of renewing your maintenance, you will automatically receive a quote for the ArcGIS user types that are equivalent to your current ArcGIS Desktop license levels. Now let's see how these migration pathways work. The ArcGIS Desktop early migration offer is a low-risk way to try out ArcGIS user types before ArcGIS Desktop is retired at no cost. That's very important. If you are ready to commit migrating to user types, Esri will convert your ArcGIS Desktop licenses to ArcGIS user types, which you can access at no additional cost until the end of your current maintenance term. At renewal, instead of being quoted maintenance, you will be quoted a renewal for user types you requested through the offer. The offer is available for both single use and concurrent use licenses. One thing to keep in mind is that you must convert all of your ArcGIS Desktop licenses at the time you accept the offer. You cannot convert only some of them, and you cannot convert different licenses at different times. The only trade-off when converting is that you will no longer be able to renew your ArcGIS Desktop maintenance. However, your maintenance is still in effect until the end of your term, and you will still have access to the software. Esri will never take away perpetual access to your desktop software, even after your maintenance expires. If you use the offer with single-use licensing, you will convert each of your ArcGIS Desktop licenses to the equivalent user type. When converting to user type subscription licenses, you can elect to convert licenses to a higher user type if your users need additional capabilities. So if you have ArcGIS Desktop Basic, you will get Creator user type, which includes ArcGIS Pro Basic, or you can choose to upgrade to Professional or Professional Plus. If you have ArcGIS Desktop Standard, you will get a Professional user type, which includes ArcGIS Pro Standard. You can also choose to upgrade to Professional Plus. And if you have ArcGIS Pro Advanced, you will, if you have Desktop Advanced, you will get Professional Plus user type, which gives you both ArcGIS Pro Advanced and a set of core ArcGIS Pro extensions. If you use the offer with the concurrent use licensing, you can request up to 3 user types per concurrent use license. When converting your licensing to user type subscriptions, at least one of these user types must match or exceed the ArcGIS Desktop license level for the license. So if you have an ArcGIS Desktop standard license, you will need to request at least one Professional or Professional Plus user type. The other 2 user types can be delivered in any combination. You can even request a user type that don't include ArcGIS Pro. For example, like a viewer, contributor, or a mobile worker. Once you convert these licenses to user types, you can't request changes to the user types you receive through the conversion. But if you find out that you would prefer a different combination of user types, you will still have the option to adjust the licensing you purchase at the next renewal. The last day that ISRI will quote ArcGIS Desktop maintenance is 1st December 2025. After that date, once your maintenance is up for renewal, you will automatically receive a quote for user types instead of your maintenance quote. So by default, you will be quoted one user type that's equivalent to each of your ArcGIS Desktop licenses. This will be the default for both single use and concurrent use licenses. However, you are welcome to request a different combination of user types so you can right size the licensing for your users. Just like with the early migration offer, you can still optionally request up to 3 user types for each of your concurrent use licenses. This conversion follows the same 3-to-1 conversion rules as the early migration offer. If you want to apply your user type licenses to ArcGIS Enterprise, you can request perpetual user type licenses. But if you decide to migrate to perpetual user types for ArcGIS Enterprise, you must request perpetual user types that match your current ArcGIS Desktop license level. You cannot migrate from ArcGIS Desktop to a lower or higher perpetual user type. This applies to both ArcGIS Desktop single use and concurrent use licenses. Whether you are migrating early or after ArcGIS Desktop retires, if you want a different combination of licenses, you will need to purchase those licenses separately. We know that some customers have requirements that can't be met through user type licensing. For these customers, we have an additional migration option. That is ArcGIS Pro Standalone. Let's talk about what it means to migrate to ArcGIS Pro Standalone. If you need a way to license ArcGIS Pro separately from a user type, you can license ArcGIS Pro Standalone. This is a perpetual license that only includes access to the ArcGIS Pro app. This means it does not give you an ArcGIS user type. So if you want to connect to content in your ArcGIS Online organization account or ArcGIS Enterprise portal, you will need to buy a user type separately on top of your purchase of ArcGIS Pro Standalone. If you are migrating from single-use licensing, you will be quoted RGS Pro standalone maintenance based on your RGS Desktop license levels. So if you have RGS Desktop Basic, you will be quoted maintenance for RGS Pro Basic standalone. And if you have RGS Desktop Standard, you will be quoted maintenance for RGS Pro Standard. And if you have Advanced, you will be quoted maintenance for RGS Pro Advanced Standalone. RGS Pro Standalone does not offer a concurrent licensing model. However, when migrating to RGS Pro Standalone from concurrent use licenses, you can request up to 3 standalone licenses per concurrent use license. Each of these licenses must match the previous RGS Desktop license level. Here are some resources on RGS user types as QR codes. In a moment, I will share the links in the chat as well. So just to summarize, like in conclusion, we discussed the user types, the updated user types, their benefits, and different pathways for migrating from RGS Desktop to user types. So as we move forward, it is important to work with your contacts at Micro Center and agree on a migration plan to user types by taking advantage of the early migration offer that is available to you at no additional cost. My colleagues at Micro Center will be happy to connect with you individually to discuss and agree on a plan from RGS Desktop to the updated user types. Thank you for your attention and participation. Back to you, Mahesh.
Thank you, Mohab. That was quite a detail about the licensing policy. Next, I would like to just carry on with the subject, with the agenda. We'll just move on. I'd like to introduce National Space Science Agency. You all know it is one of the most premier space science agency in Bahrain. Quite a young agency too, and it is going to be presented. Engineer Suad Mohammed is going to represent NSSA and talk about a practical interpretation of spatial data analysis across different areas of application. Engineer Suad Mohammed is actually a space data analyst from the Satellite Imagery and Data Analysis Laboratory. Thank you, and Engineer Suad, can you please take over?
Thank you so much for the kind introduction. I'll share my screen now. Just please let me know if you can see it.
Yes, we can see.
Okay, I'll begin now. All right, so hello everyone, good morning, and thank you for taking the time and joining today's discussion. I'm honored to be one of the speakers for this year's GIS Day virtual event, representing NSSA and speaking on the topic of how GIS data can be integrated into many fields of application beyond geography. So my presentation is titled The Practical Interpretation of Spatial Data Across Different Areas of Application. And throughout this presentation, I will basically explore diverse applications of GIS and discuss the concept of data interpretation. I will also give examples on how these data and indices contribute to achieving many objectives, especially those related to UN Sustainable Development Goals. Now, before I begin, I would like to briefly introduce myself. My name is Engineer Saad Mohammed. I'm a space data analyst with the National Space Science Agency here in Bahrain. I've had the privilege of working on projects that are directly tied to the subject matter of today's discussion. These projects involve the application of GIS to analyze, interpret, data in ways that are relevant in addressing a wide range of real-life challenges. I will get into some of these projects in today's presentation as well. So, okay. So before we begin with the main topic of today's presentation, I would like to provide a brief overview of NSSA. NSSA was founded in 2014 by Royal Decree Number 11, and since its establishment, the agency has achieved great milestones in terms of forming a framework for creating a national space section here in Bahrain. Our vision at NSSA is to take Bahrain to a position ranking with developed countries in space science that enables achieving comprehensive and sustainable development. Aligned with this vision is our mission, which is to apply integrated initiatives and programs to respond to national requirements and to sponsor and develop space scientific technological activities, research, and concepts for achieving comprehensive and sustainable development. So looking ahead to the period between 2024 and 2028, the agency has outlined a set of strategic goals aimed to contributing to the progression of the space sector in Bahrain. First, we have the development of national talents. It's very important to empower local talents and build on skilled workforce that can drive the kingdom's space initiatives forward. By offering training, education, and hands-on experience opportunities, the agency shows its commitment to both its mission and vision by investing in one of the progress drivers, in this case, national talents. Secondly, we have approving the principles that regulate the kingdom's activities in the field of space. This is important to ensure that all space-related projects are conducted in accordance with national and international standards. This is also important for providing a clear framework for future ventures while ensuring safety, security, and compliance. Another key goal is constructing a sound infrastructure. This is done to support the space sector and satellite activities. NSSA is also committed to contributing to a sustainable national economy. By leveraging space technology and data, NSSA aims to support industries like agriculture, energy, and urban planning, which promotes economical growth and resilience across these sectors. We at NSSA also recognize the importance of encouraging, supporting, and developing scientific research programs. Through these initiatives, NSSA aims to enhance knowledge and contribute to global scientific community by contributing through research in space science and technology. Another goal is the establishment of relationships of cooperation, which is, of course, a key in building strong partnerships with other regional and international space agencies, which also include research institutions as well as entities in the private sector. These collaborations play a huge role in encouraging knowledge exchange and collective progress in this industry, which is the space industry. And finally, we have the last point, which is NSSA is dedicated to providing satellite data and analytical studies to support data-driven decision-making. By offering these images and studies, the agency aims to support and empower both governmental and private entities in their respective fields. As I mentioned previously, NSSA offers services to support the kingdom's space science and data initiatives, and these services include providing high-quality satellite images and space data of Bahrain's land and territorial waters. These satellite images are available in both recent and archived formats across low, medium, and high resolutions, and in various spectrums. The next service is related to processing these satellite images and data. Offering advanced satellite image processing services enhances the accuracy of satellite data and ensures that these data are considered reliable and provide precise results for land and water monitoring studies. Another service would involve integrating geospatial data from different spatial and spectral resolutions to build detailed and accurate geodatabases. Combining data that have different specifications allows for the creation of comprehensive reports, and these reports can provide valuable information to support decision-making in many fields, like urban planning, environmental monitoring, resource management, and many more. And lastly, NSSA also provides technical support for all of its services. It also offers training for governmental entities and organizations on spatial analysis techniques through specialized workshops. Okay, so moving to today's main topic in this presentation, which is data interpretation. What is data interpretation? Data interpretation involves the process of analyzing data to draw meaningful conclusions. This is done to identify patterns or generate insights in general. This process is often tailored to specific contexts or objectives, which might vary depending on the analyst's backgrounds or the project's area of focus. For example, this is a satellite image you can see here of a town. If we were to consider an urban planner, this is example. We were to consider an urban planner. Let's say he's planning to expand the city. More focus will be drawn to coming up with solutions that take into consideration the current state of the buildings in the area and their infrastructure. They might trace the existing pattern of buildings in this image and come up with an expansion plan considering the vegetation growth on the outskirts of the town. Another analyst that is more interested, let's say, in agriculture, for example, an environmental scientist, might look at the same image and focus more on the distribution of green areas in the city. This image also shows a map or a layout of the roads that run through the town, which means that it can also be used to assess the flow of traffic or maybe plan for infrastructural improvements and road modifications. The idea is each analyst might use the same data, the same information present in this image and interpret it differently. This interpretation depends on their personal goals and what they want to achieve by the end of their analysis process. Now, the analysis process or methodology can vary, again, depending on the nature of the project and the analysis specialty. However, I'll go through the general 6-step process that is followed at NSSA for analytical studies, starting with research and requirement gathering. The first step is to understand the objectives of the project and gather the necessary requirements. This involves basically identifying the key stakeholders, defining the scope, and determining what type of spatial data is needed for this project. The second step is satellite imagery and data collection. Now, once we know the scope, once the requirements are clear, the next step is to collect relevant satellite imagery and spatial data. This can include both remote sensing data, such as satellite images, or secondary data sets like topographic maps or demographic information. The next step is data preparation and pre-processing. In this stage, the collected data undergoes preparation and cleaning to ensure that it is actually reliable before it's used. This may involve removing noise, correcting distortions, aligning data sets from different sources. This stage might also involve things like clipping the data, subsetting, and mosaicing. Moving on to the data processing step, during this phase, we explore the data, and if we need indices, we calculate them. If this analysis involves the development of machine learning algorithms, then this development is also done in this step. The fifth step is data analysis, which is basically the core of this entire methodology. This is where we use whatever we developed in the previous step to analyze the data, to look more into the data. We extract meaningful patterns, trends, and insights. The calculated indices and the developed algorithms, again, are used to make sense of this data and come up with relevant findings. Here is basically where most of the variation in data interpretation takes place. This step focuses on the actual extraction of results and coming up with conclusions, which again can differ from one area to another. Depending on the project's objective, the analysis might involve overlaying different data layers, performing spatial queries, or applying statistical models. Lastly, we have data visualization. This is the final step in the analysis, where the findings are presented in a visual format, which can be maps, charts, graphs. This is done to make the findings easier to understand. But one thing worth mentioning is that visualization techniques can vary significantly depending on the target audience, and the type of data that's being presented. So now that we have discussed the process of analyzing spatial data, it is very important to recognize that interpreting these data comes with its own set of challenges, one of which being uncertainty and data inaccuracy. Uncertainty and inaccuracy in spatial data is one of the most common challenges faced. Spatial data can come in different resolutions, different specifications, and if the application highly depends on the extent of image clarity or resolution, accuracy can be affected a lot if the required data specifications are not available. And of course, uncertain data can lead to incorrect conclusions, especially if we are using machine learning models that are highly affected by inaccuracies and rely on the quality of the provided data for training. Another challenge would be the complexity of data integration. Sometimes studies require combining data from different sources. And although having more data available for analysis is good, the process of combining them into the same data set can be lengthy. And in order for data to make sense, they have to be consistent. And that's not something that can be guaranteed when these data come from different sources. Again here, ensuring that the used data is consistent highly affects the accuracy and the reliability of the results of the analysis. Lastly, we have the last challenge, which is basically data equality and integrity. The quality of the data is not only limited to the spatial resolution or consistency, but it's also dependent on how recent is the data. This is especially the case for applications that are considered related to disaster management or urban change. In order to make beneficial recommendations in these cases, incomplete or outdated data will not allow us to come up with comprehensive recommendations. Another data quality issue can be the redundancy as well. Data needs to be properly cleaned to prevent redundancy since it can cause bias. For example, if we're working on developing a machine learning model, redundancy can cause a huge issue. Okay, building on the challenges I have just mentioned now, it's important to talk about the important role that the availability of different data types can play in terms of overcoming these challenges and enhancing data interpretations. Here are some of the many data types available for analysis. When we have access to diverse data types like optical data, thermal, DM, and radar data, it provides more context for our studies. For example, high-resolution optical data can help us observe surface features like vegetation, land cover, and urban areas. It can also be used for mapping and land use classification. Thermal data can provide insights into temperature variation in the study area and across surfaces, which is helpful for applications related to environmental monitoring, like urban planning, like urban heat islands and its effects, for example. Another type of data is DEM, or digital elevation models. This type of data is important for understanding topography for applications that are maybe related to disaster management, for example, like assessing flood risks in the area or even modeling the damage done by earthquakes. As for radar data, it has the advantage of being unaffected by weather or light conditions, which makes it ideal for studies that focus on areas with frequent cloud cover or those concerned with forest areas with a heavy canopy cover. So overall, I can say that integrating these data types, these ones mentioned here and many more, it helps us find or gain more context on the field of study that we are focusing on or we're interested in. And it opens more doors for interpretations to be made for this specific field. Now that we've looked into how integrating different data types can provide more comprehensive insights, this takes us to our next point, which is data for sustainable development. Different data types can lead to more results that could contribute to many areas of applications, most of which are included in the Sustainable Development Goals shown here. The Sustainable Development Goals, or the SDGs, help us understand the extent of the diversity of GIS applications across many fields. In Our Common Future report, the World Commission on Environment and Development has defined sustainable development as development that meets the needs of the present without compromising the ability of future generations to meet their own needs. Now, this principle is the essence of the 17 SDGs, which were adopted by the United Nations in 2015. The SDGs cover the wide range of issues that we talked about, and it ranges from eradicating poverty and hunger to promoting the importance of climate action and sustainable cities. By using GIS, we can monitor, analyze, and visualize spatial data related to these areas. As I mentioned, GIS data can be applied across many fields, each contributing to the achievement of the Sustainable Development Goals. In this presentation, however, I'll mainly focus on three areas, which are agriculture, climate change, and urban planning. Starting with agriculture, GIS can offer insights on things like crop health, soil conditions, and seasonal changes. The second area, which is climate change, GIS helps monitor environmental changes and assess the impact of these climate changes on the areas of interest that we have. Another area would be urban planning, the last one. And GIS can also be used on this one to analyze land use, detect changes in infrastructure, and even optimize resource management, which are all related to urban planning. Starting with the first area, which is agriculture. For agriculture, we have two projects. The first one being green coverage before and after afforestation plan. The GIS was used here to monitor afforestation in areas following the initiation of Forever Green campaign in Bahrain. Forever Green campaign was initiated in 2021 under the patronage of Her Royal Highness Princess Sabika bin Ibrahim Al Khalifa, wife of the King of Bahrain and chairperson of the Consultative Council of the National Initiative of Agricultural Development. The main aim of this campaign is to implement afforestation projects and increase green areas in Bahrain. So the campaign first started phase one of its operation in 2021 after the COVID outbreak. And although we can see an initial recovery in green areas prior to that, the growth of these areas is further expedited by this campaign. The study was possible to carry out by using NDVI index, or the normalized difference vegetation index that we use to locate green covered areas, as you can see here on the example map provided. The area in bright green represents areas with high vegetation, and a map of Bahrain similar to this one was made for each of these years in June to track the change found in vegetation and help us visualize these changes more clearly. This application here shows the efficiency of monitoring greenery in a specific area of interest and tracking the progress of projects or initiatives, in this case for Forever Green campaign on the environment. Another study for agriculture would be soil salinity, which is a study conducted in 2022 by monitoring and classifying soil moisture levels. We can better understand areas that require this study helps us understand these areas that require additional irrigation or where crops might be at risk due to drought or flooding. This data can help in making informed decisions on irrigation management, crop selection, or just overall agricultural practices. The study's main objective include evaluating the overall soil moisture percentage within each of Bahrain's governorates, and investigating soil moisture content across the entirety of Bahrain, including mangrove areas. Landsat optical images were utilized here, along with the SMI index or soil moisture index. The resulting analysis visualization, as you can see on the map here, is an image shows a clear picture of soil moisture distribution across Bahrain. This analysis again was done in 2022. So this image shows that in this year, the majority of the soil in Bahrain was of a moderate moisture level. These pie charts also provide more insights into the percentage distribution of soil salinity levels, soil moisture levels, categorized as dry, moderate, wet, and extremely wet for each governorate in Bahrain. Moving on to the next area of application is climate change. The first study that I'm going to talk about here is land surface temperature. Land surface temperature refers to the temperature of the Earth's surface as measured by remote sensing technologies. And for this study, thermal maps of Bahrain were created with areas in deep red in the map here, representing regions with high LST, and those in lighter shades are indicating areas with lower temperatures. Optical data were used here and thermal data as well to analyze LST and calculate this index. By using GIS data, we were able to track changes in LST from 2019 to 2023. Of course, further investigations for a bigger time period might be able to provide us with more information regarding patterns or trends about or seasonality. But for this study, we focused 2019 to 2023. And for these years, we found that at 2021, the LST reached its maximum in Bahrain for this period. And after that, it decreases notably with time. Now, knowing the land surface temperature of an area plays a crucial role in understanding other environmental elements and phenomena like urban heat islands, for example, or even we can relate it to the growth of vegetation. We can also say that monitoring these temperatures over time helps us in assessing the effectiveness of mitigation strategies against elevated LST temperatures as well. The next study also falls under the climate change category and it focuses on air quality monitoring. Optical data were used here as well as Sentinel-5B data. Sentinel-5B is a constellation of satellites launched by the European Space Agency. These satellites are equipped with instruments that are capable of measuring gas columns. These gases include a wide range like nitrogen dioxide, sulfur dioxide, ozone, methane, and many more. For this study, however, we mainly focused on nitrogen dioxide and carbon monoxide, NO2 and CO, in Bahrain, which are two important pollutants that have a big impact on human health and environment as well. The map displayed here shows the distribution of NO2 concentrations across Bahrain. And this visualization helps us basically pinpoint hotspots and understand the main sources of these pollutants, which are usually linked to industrial activities or vehicle emissions. Similar to LST study, previous maps were made covering the year 2019 to 2023 to capture changes in both nitrogen dioxide and carbon monoxide over time and study possible causes of elevated air pollutants during this time. For example, in 2022, here we can see that nitrogen dioxide reached its max value according to the data. Moving to the next area of application, which is urban planning. The first study focuses on building detection. High-resolution optical data were used for this study, and it allows for the identification of buildings within study area. In this case, the area is Diyar al-Muharraq, and this project utilizes GIS along with machine learning techniques for building detection, where a model was trained to recognize patterns in the data and classify pixels accordingly as buildings and not buildings. The map displayed here shows how the model was able to detect buildings in the area, and the graph also illustrates how this application also allows for tracking the change in urban growth. More building areas were detected in 2024 than in 2022, which basically provides insights into urban expansion, and it can also help urban planners understand the rate of urban growth and anticipate future infrastructure needs like transportation in the area or utilities. Before I move on, it's very important to highlight the role of machine learning in modern day GIS in general, and for this study in particular. The use of machine learning allows for processing of large datasets in less time than the time required to analyze them the traditional way or manually. This means that it basically enhances the accuracy and efficiency of the analysis by providing an automated solution that in case of urban planning can enable better resource allocation and management. Another study for urban planning is urban heat islands, or UHI. Now, this study can also be looked at from a climate change perspective, but it also falls into under urban planning because it also contributes to this field. Urban heat islands refer to urban areas that experience higher temperatures than surrounding areas. This can be done. This is happening due to human activities and the concentration of built-up surfaces like roads, buildings, and concrete. These areas tend to absorb and retain heat, causing temperatures to rise significantly, especially during the summer. For this study, thermal data was used to identify urban heat islands using LST index, and UHI maps were also created for this period 2019 to 2023, showing the distribution of heat islands in Bahrain. On the map, as you can see here, the areas in red show urban heat islands, whereas the areas in blue show urban cold islands, where the temperatures are lower than the surrounding urban islands, which is the opposite. This is happening due to green spaces or water bodies. By analyzing these UHI maps, we were able to track the changes in relative frequency of urban heat islands, as you can see here in the graph, over the years. And as of 2021, UHI relative frequency in Bahrain is slowly decreasing. So those were examples of studies done at NSSA that covered these individual sectors: agriculture, climate change, and urban planning. Again, GIS is capable of covering many more applications. GIS allows us to bring these separate domains together, basically. And this is done by integrating data from these three sectors and assessing ways in which they are correlated or how they can influence one another. With this, GIS creates opportunities for collaboration between professionals in different fields to serve a common purpose or goal and addressing the challenges that are encountered by these professionals during their work. And the fact that we can correlate these areas together, addressing these different issues from these different sectors all at once, is actually good. It provides more inclusive solutions, ones that balance the needs of each sector without compromising any of them. For instance, I can give you examples. We have agriculture and climate change. If we were to combine the results of these two studies, one focused on grain coverage, monitoring for agriculture, and another on land surface temperature for climate change, the chart here shows two key trends over time. The first line representing the increase in grain coverage in the area, while the second line shows a corresponding decrease in land surface temperature over the same time period. In this analysis, it was found that a strong negative correlation exists between these two sets of data, which basically insinuates that there is a possibility that areas with high land surface temperature levels can be regulated by increasing green coverage. It's very important to mention here that while increasing green coverage is considered a promising solution for mitigating LST, other factors should also be considered, like soil quality, water availability, local vegetation types, and so on. Similarly, we can link agriculture with urban planning, especially when it comes to addressing urban heat islands. Initially, this observation was done through visual inspection of NDVI and UHI maps that are of the same date or approximately close to one another to see if greener areas experience less of urban heat island phenomena. A visual inspection of both maps did prove this assumption to be true, because we were able to see that areas with higher green coverage tend to have fewer or less intense urban heat islands, where areas with lower vegetation are more susceptible to high temperatures. It is, of course, very important to validate and back up these initial inspection observations with actual data of the correlation between grain coverage and the relative frequency of UHI. And this in turn revealed a strong negative correlation again between these two factors, which suggests that expanding green areas through greening initiatives like Forever Green or the general improvement of agricultural management may help in mitigating effects of urban heat islands and also contribute to improving overall urban climate. This combined analysis demonstrates how this example and the previous example demonstrates how GIS was able to bridge the gap between agriculture and urban planning, allowing for meaningful solutions to come into place and addressing modern day issues and challenges. Similar relationships can be done with a lot of other factors using GIS as well. These are other examples of major projects sent by NSSA, and these projects, along with the projects that I've talked about already, cover a wide range of applications or application areas, including disaster management, like oil spill detection, environmental monitoring of water bodies and water quality, as well as other projects related to agriculture, like palm tree count and health monitoring, or for example, in terms of urban planning, we have land use classification and many, many more. These studies utilize different types of data to address many challenges and also contribute to the achievement of different SDGs in many areas of application. Before we conclude today's presentation, I would like to touch on some important ethical considerations that are essential when working with GIS data. As GIS continues to play a big role in many sectors, it is important to recognize the responsibility we bear as users when handling and analyzing spatial data. There are two key points we must consider. The first point being the responsible use of data. GIS data can have significant implications, especially when it influences decision making, which can affect communities, environments, and even policies. It is our responsibility to ensure that the data is being used ethically and with full transparency and accuracy, because misinterpretation or misuse of data can lead to harmful consequences on individuals, entities, and even on communities. So it is very important that we adhere to ethical standards and ensure that the data serves its intended purpose and without harm. The second consideration is data privacy and confidentiality. GIS datasets can contain sensitive information. This information can be related to individuals, properties, organizations. As GIS professionals, we must be mindful of these privacy concerns and make sure that the data is secure by following protocols to anonymize data and restrict data access to authorized individuals only. This is important because breaching privacy or mishandling sensitive data can affect or damage the trust we have in GIS applications. Thank you so much for your time and attention throughout my presentation. If you have any questions or would like to discuss any other topics covered in this presentation in more detail, please do not hesitate to contact us and reach us. Once again, thank you for having me. It was a pleasure.
Thank you, Engineer Suad. That was quite an insight on NSSA and how you use GIS and remote sensing. I would like you to say to stay tuned because we have something more interesting coming up, which not only NSSA and other agencies would be quite interested in. So with that, I'll just if you have any queries, we can always take it. We can take it at the end of the session to save on some time. So you can put your queries on the chat box and we can take it to the end of the session. So to move on to the next agenda, we have the Information and E-Coordinate Authority with the presentation on the BNITE's GIS Excellence. Let me just quickly introduce the speaker. Mrs. Jawahar Rashid is a senior ICT specialist from the GIS Directorate of IGA. With this short introduction, I'd like to hand over the screen to Mrs. Jawahar so you can carry on with the subject. Thank you.
Thank you, Mr. Mohesh. If you will allow me to start with introducing myself, this is Jawahir Rashid Al-Buthalah. I'm a senior ICT specialist at the Geographical Information System Directorate within the Information and E-Government Authority with an over a decade of experience in business and system analysis, and I played a humble role in a number of national system transformation and re-engineering process. Currently, we're working on the Binayat building permit system and other GIS systems related to the infrastructure permits in the Kingdom of Bahrain. To start up our presentation, we'll have just a quick brief regarding the Binayat building permit system, which is a system used to issue building permits for all type of projects within the Kingdom of Bahrain, whether it's investment, residential or commercial projects. And the systems allows the applicants which is the licensed engineering officers or the property owners to apply for building permits, inquire regarding the application statuses and obtain the necessary consultations from the concerned governmental entities and approval regarding the building permits and pay all the related building permit related fees and apply for the other building permit related services. Through Binayat, we have utilized the interactive maps to provide a key information and details for the land parcels, and by centralizing all the concerned regulations and laws and requirements under one system to facilitate the process of building permits issuance and construction field in Bahrain. Here we'll just highlight the main objectives of the system. The system aimed to transform the government role from operational to regulatory role and unifying the guidelines of the building permits regulation and make it available for all the developers and the engineering office and all the owners interested in the building permits fields, and to provide a faster provision of building permits and essential utility services, in addition to a better governance and urbanization planning and effective utility service delivery. Here we will highlight some of the key achievements and success throughout Binayat journey. Throughout this year, in addition to the new construction, we have re-engineered and prepared the studies for around 12 other building permits, which are the big addition building permit and the small addition building permit, in addition to the governmental project permits and telecommunication towers permits and the demolished permit, in addition to the marine and land reclamation permit, separation and merge permits, renovation, boundary walls, and change of usage nature. Here, worth mentioning that among of these services, the services that are currently live and available into Binayat systems are the big and small addition building permits, government projects, and telecommunication tower permits. Throughout our work through these building permits, we have achieved some key achievements, which are the re-engineering of these service procedure were fully transformed and available fully electronically throughout Binayat system. And we have accomplished the reducing of the number of required approvals from the governmental entities for all of these building permits for around 82% compared to the current system. And in addition, we reduced the time required to issue the permits by around 88% as a service level agreement compared to the current state of the process. Additionally, we automatically distribute the requests received through Binayat system to either public or private entities based on the required approvals, based on specific inputs, and based on the area by utilizing the latest GIS technologies and spatial conditions. In addition to that, we also integrated Binayat system with other systems to automate the verification of the applications, such as the municipality system and the CRS system and Sigillat system. In addition to that, we provide an interface and improve the user experience for either the governmental entities and the engineering offices and all the users engaged into Binayat system. In addition to that, we try to unify all the services information published throughout all the channels and automate some of the forms involved in the current state of the services and provide them electronically into Binayat system, and that affects the number of required documents that was attached and provided by the applicants by the applicants of Binayat. In addition to that, we facilitate the payment process by allowing the payment of all the related fees of all the involved entities into Binayat system into a single payment mechanism and a single payment platform. We also provide the ability to issue and print the building permit automatically from the systems, and that happens after completing the payment process through Binayat system. Here, if you'll allow me, we'll just have an insight of some of the important numbers that was captured through Binayat systems. Currently, the number of involved entities into Binayat system are around 17 governmental entities. And the number of users involved into Binayat system, including the engineering offices, owners, and governmental entities, are around 1,838 users. And the total income into Binayat system was 515,389 BD. And if we're going to move to the number of issued building permits and the number of issued NOCs from Binayat system, the number of issued building permits, including the new construction building permits and the small and big addition building permits, were around 1,920 building permits with an average issuance time of 3 working days. And the number of issued NOCs, which is the completion certificate, was around 750 building permits with an average issuance time of 3 working days. And these statistics were captured from January till the end of September 2024, which is the third quarter of this year. Here we'll zoom into one of the services that were recently studied, and it is actually currently in the development process with the development team. Here we will highlight a case study showing the number of entities available in the current state of this process and compare it to the proposed solution. Here, as you can see, that the number of entities were involved in the current state of the renovation service were around 18 governmental entities. And just to clarify one point, the renovation service is meant to issue a building permit to make some alteration and updates into a current available system inside without adding any additional area to that building. And now comparing to the 18 available governmental entities in the current states, we have reduced the governmental entities approval to 7 governmental entities. And the entities were also reduced due to the automation of some conditions and assigning some of the roles of some of the entities to the municipality as they are the reviewer entity in this kind of building permit. Here, if we want to highlight the proposed number of entities, these entities will receive the renovation service based on certain conditions. For example, for the Ministry of Industry and Commerce, they will receive the request based on a predefined set of areas or fencing areas available in the GIS layer provided by MOICT. And the entity will receive the request whenever the application or the parcel is falling into one of the areas specified by the Industry and Commerce Ministry. And that point will also apply for the Ministry of Oil and Environment as per the areas were already provided by the ministry and implemented and available in the PSDI, which is the Bahrain Spatial Data Infrastructure Portal. They will receive the request whenever the request is falling into the areas specified by the ministry. And that will also apply for the Bahrain Authority of Culture and Antiques, BACA. They will receive the application whenever the application is falling into the area specified by them into in the BSDI. In addition to some other conditions, which is specifically if the building is over 50 years old, they will also require to receive these kind of requests and review these requests. And regarding the Road and Planning Design Directorate, they will also receive this kind of request if it involves a new opening for new entrances. The request will be forwarded to the Road and Planning Directorate based on the user input and the details of the request. In addition to that, we will move to the General Directorate of Civil Defense. It will also depend on the details of the request, since whenever the renovation will include cladding to the surface or the outer area of the building, the Civil Defense will receive this request for their review. And regarding the Electricity Distribution Directorate, they will receive the application whenever the applicant required extra electrical load. If there is an extra electrical load required, the application will be forwarded to the Electricity Distribution Directorate at EO. Finally, the Ministry of Finance and National Economy, they will receive the request whenever the request is located in one of the governmental properties. They will receive it, as we mentioned, as per the as per the applicant's input and the application details. Here an overview of the comparison of all the re-engineered permits and the comparison among the number of entities in the current state and the number of entities and the proposed solution, as we mentioned and explained in details in the renovation permit. If we will go into each permit, the small addition permit were reduced from 22 governmental entities to 9. And the big addition were reduced from 22 governmental entities to 11 governmental entities. And the telecommunication were reduced from 10 to 7 governmental entities. And the demolished permits were reduced from 22 governmental entities to 4. And the boundary wall permits were reduced from 19 governmental entities to 6. And the separation and merge building permits were reduced from 18 governmental entities to 9. And the change of usage nature permit will also reduce from 19 to 11. And as we just elaborate and mentioned that the entities were reduced whenever the condition could be automatically implemented into the system, or the role of these entities were available in the guideline of the building permit, where the governmental entities can view and follow, or their role will be transferred to the reviewer entities, which can be the government to a reviewer engineering office or the municipalities. Here we will move to some of the main GIS features and other used technologies available into Binayat system. Here, the functionality of the Bahrain map is also provided through Binayat system to search and view for any required area or specific parcel, and to view their specifications as per the UPDA zone specifications and the service indicator details. Here, as you can see in the screenshots, the user can access the Bahrain map, and they can search for a specific parcel number, or they can search by the block number or detailed coordinates, or they can search by the detailed address specification, including the building number, road number, or the block number. Whenever you enter for example, the parcel number, the map will zoom in into this parcel number, showing all the detailed specifications of this parcel number, including the detailed information and the zoning regulation details of this parcel and the zone located within this parcel. And in addition to that, we will see the regulation specified by the CAA, specifying the maximum allowed height for this parcel, or for example, for this whole zone. And we can also view the service availability indicators, including the road, electricity, water, and sanitary, whether these services are available into this parcel or not. In addition to that, the navigation functionality is also available within the Bahrain map available into Binayat system, allowing the navigation through the Google Maps. Here we will move to another GIS-based feature available into Binayat system, specifically into the road occupation service. Whenever the user apply for the building permits and the building permits were issued into Binayat system, the user will be allowed to apply for the other permits related to the building permit, such as the advertisement, road occupation, addresses, and the service connectivity, and so on. Here we will highlight the feature implemented into the road occupation service. Here the user will be required to state the start date for the road occupation. And the user will be required to use the available map to indicate the exact location of the road occupation that will be required to be used and the exact area. And by identifying the exact area, it will allow the system to automatically calculate the road occupation fees and insuring fees based on the zone of the parcel that was captured from the map. And the road types were also identified in the BSDI maps regarding all the roads available on the map, and the road occupation area specified by the applicant, as you can see in the screenshot. And in addition to that, the road occupation period that was specified. And based off the criteria, as we mentioned, the road occupation fees and insurance amount will be calculated. Here we will move to some of the highlighted challenges and underlying solutions for each of these challenges. Throughout our working into Binayat system, we have faced some unclarity in some of the regulations that encourage us to engage deeply with the regulatory bodies in early stages to consolidate and clarify all the regulations associated with Binayat system and the building permits. In addition to that, we face some tight timelines, and that encourages us to develop a detailed project plans with a buffer times to fit the desire of the business owner and the ability of the available team in either the development or the business side of the analysis. In addition to that, the extensive implementation efforts that lead us to define a breakdown for the project into manageable phases and prioritize these tasks in order to deliver these project functionalities and requirements in the time required. In addition to that, we face some communication and coordination issues that encourage us to establish a clear communication channels and use the project management effective tools. In addition to that, regarding the resource management, we conduct through a resource assessment and develop a predefined contingency plan for the resource management. In addition to that, we address some unplanned requirements that encourage us to implement a strong change request management process that we strictly follow with the business owner. In addition to that, the data management issues, we standardize all the data formats and the use by the integration tools to minimize any data errors or any data misleading throughout the applications of the project. In addition to that, the complex stakeholders, we defined a stakeholder management plan and identify and update these stakeholder lists regularly. Here we will move to another part of the presentation, which is the most promising future innovations that we are currently working on and taking into consideration for the future plan. First of all, we will highlight the future of the Binayat system in terms of the services available into Binayat. Currently, we are working for the development for the other permits of Binayat, which are the services pre-issuing the building permits through Binayat, including the construction initial stage and the address service that comes after issuing the building permits, in addition to the service connectivity stage and the construction follow-up stage and the issuance of the construction completion certificate and finally the insurance refund. In addition to that, in the GIS Directorate, we are focusing on the new upcoming project, which are the BSDI portal upgrade and the BIM and 3D solutions. Here, if you'll allow me, we'll just go a bit deeply on the way forward for the BSDI portal upgrade. The new portal will also enhance the current GIS capabilities and support the future GIS requirements for the government through a better data management and adding some new capabilities of artificial intelligence solutions and advanced geo analytics, and encourage and adding the open BIM technologies, all integrated within one secure platform. Here we will go just to highlight some of the project scope that will be implemented within the BSDI portal upgrade. We will take into consideration the enterprise portal implementation, and here we will highlight some of the online services that will be supported by the new BSDI portal, which is the enterprise portal services and the ArcGIS REST services, in addition to the Open Geospatial Services WMF and the WFS and any other on-custom requirements, in addition to the Open BIM portal services and the Geo Artificial Intelligence and the Geo Internet of Things. In addition to that, we took into consideration the portal admin platform and the BSDI metadata portal. And this point will highlight that the admin platform that will be managed into the BSDI portal administration will be addressed effectively and efficiently. And the metadata standards and the specification will be identified to make it available into the BSDI portal. In addition to that, we will take into consideration the SDI GIS incremental data update automation implementation that will ensure the incremental data update for the spatial data from all the data source and all the governmental entities involved into the BSDI. In addition to that, the infrastructure for enabling IoT, which is the Internet of Things within the GIS environment, S3 Geo Event Service also will be provided for integrating and managing the Internet of Things data within the spatial environment and the geo environment and data. We will also enable the Geo AI environment and build the Geo AI solutions. We will make sure that the BSDI infrastructure will also include the Geo Artificial Intelligence environment that will utilize the Geo AI and the deep learning capabilities to build the Geo AI solutions based and to fit the governmental priorities. Here we will move to the second key solution that will be implemented in the future coming phase, which is the BIM and 3D solution. The BIM also will provide will provide for the building permit approval process more to make it more efficient, and encourage reducing the time and effort required for the project to be approved and underway. Here we will highlight some of the key goals, which is the enhanced virtualization. BIM also will provide a 3D modeling to propose the structures of the building and make it easier for the permitting authorities to understand and view and review the project, which was submitted by the applicant, and that will lead to a faster approval. In addition to that, we will automate the code appliances. BIM will automate the building code and regulations available in the government in the Kingdom of Bahrain. And by coding and providing these codes into the BIM technology, this will allow the automation of checking these building codes and to reduce the need for the manual reviews. This automation will ensure that the design will be complied with the local standards, and that will reduce any minimum delays that may come later, or any delays in the construction process. In addition to that, we will improve the collaboration. The collaboration among the architects, engineers, and the regulatory bodies, by sharing a common model that all the bodies involved in the process will understand, and will allow them to work together for more efficient and address all the issues that may occur in the design phase, and fix them in the early stage of the planning. In addition to that, we will reduce the error and revision process. The detailed nature of the BIM models will also help identify any potential issues that can occur into the construction process begins, and will reduce also the number of revisions required before the approval process. Finally, the efficient data management BIM will enable the electronic submissions of all the detailed modeling and associated data to streamline all the documentation and documentation process required, to make it easier to view and to track and manage all the applications submitted into Binaya system. Thank you all for listening. It was actually my pleasure to be here and present this to you. Thank you all for listening.
Thank you, Mrs. Jawahar. It was quite a enlightening conversation. I mean, a discussion on the achievements of IGA. I'm sure the country is very proud of the digital transformation that you are taking us through. There are some questions if you would like to take. We can just we can go through them. There's a question from Mrs. Selvaraj Krishnan. Is there any limit of building area in square meters? Will it apply in building permit Binayat application?
Yes, Mahesh, if you'll allow me. Based on the zone regulations specified by UBDA for each zones available in the Kingdom of Bahrain, each zone specify the maximum number of the square meter or the net build-up area for the buildings that will be included within this specific zones. So by reviewing the regulatorily and the detailed of the zone that the parcel is falling in, the applicant will know the maximum number of the net build-up area for this specific zone. Thank you.
Thank you. There is also another question. I think this would be apt for Engineer Suat. What resolution is used for building detection? Is it possible to identify open spaces?
Yes, if you allow me, resolution for the buildings, I don't have a specific number, but it's definitely high optical high resolution images. And for the second part of the question, which is identifying open space areas in whole Bahrain, I think you're referring to the building detection study that I talked about. And for this study, we only made it on Diyar al-Muharraq, which is, if you're not familiar with it, it's a small area in Bahrain. If we're talking about the whole Bahrain, this means that we would definitely need more computational resources. And to be honest, I can't tell you exactly yes or no if it's possible, because I would definitely have to look more into it in terms of data availability and your specifications. You're talking about open space areas. So what do you exactly mean by that? Do you have any category in mind or something like that? And again, whole area of Bahrain again needs to be looked into because
I
this
understand it's quite an
specific.
open-ended question. Yes.
Yeah. But entirely, I can say that in terms of small areas like Dir Muharraq with buildings, I can say that yes. However, whole Bahrain is. I would need to look more into it.
Okay. Thank you very much for that.
You're welcome.
There is one I think probably would pretty much suit you. I think you already gave a presentation on that. I'm just looking into that. Is there a way to detect emissions in the country through satellite?
Yeah, so that's basically, I think you're referring to the air quality study that we've done.
Yes.
How we did it is using technology, Google Earth Engine technology basically, and Sentinel 5P data. We were able to access Sentinel 5P data through Google Earth Engine. It's available there. We would obviously need to provide a shapefile of the area that we need because we don't want all the data, we just want data on Bahrain. The extraction was done from Google Earth Engine, and further processing was done also on ArcGIS Pro, but for visualization and analysis. But mostly the extraction of data was through Google Earth Engine.
Thank you. So I believe that we will just move on to the next part of the presentation. So I'd like to welcome our next speaker, Dr. Shankar. Dr. Shankar is based in Sydney. He represents Earth Eye Space. It's a very disruptive kind of technology that he has brought in Earth Eye Space. I would like to officially do a soft launch of Earth Eye Space platform in this presentation. Shankar, are you available?
Thank you, Mahesh. Appreciate that. Can you hear me?
Yes, over to you.
Okay, great. Thank you. Can you hear me?
Yes, you're quite audible. Yes.
Excellent. Thank you. Right. So I understand I have 10 minutes. Am I right, Mahesh?
Yes, you have 10 minutes.
All right. Okay. Right, folks. So I'll get through like a rocket ship. It's like Mahesh said, it's going to be an introduction or a soft launch. And if this is of interest, you can always reach out to Mahesh or myself. So I am not going to assume that either one or most of you have heard about us. So I'll spend 30 seconds to tell you who we are. I understand in Bahrain you have Uber, you have Uber Eats. That's who we are. We are Uber and Uber Eats for satellites, particularly for Earth observation, which is the topic of today's discussions with GIS. So I think the speakers prior to me set the stage very well because they talked about data processing pipelines and various applications. We are going to talk about removing friction in the acquisition of data, because what you might know is unless you are highly reliant on public source data, Sentinel, Landsat, and so forth, if you're talking about getting access to commercial data, and there are lots and lots of them, there's a tons of friction, particularly if you want them, just like how you call an Uber, if you want them on demand, access on demand, when and where you need, what sensors you need, and more importantly, at the price point we need. So you can't assume that everybody is have unlimited resources like defense agencies, who happens to be our number one segment, but there are also a number of governments and commercial customers. We enable this acquisition of spaceborne data or Earth observation data and the use of it. So essentially our mission, Earth iSpace, is a Singapore headquartered company, and we founded this about 20 plus months ago. And my background is I was one of the early VPs at Planet, worked across Satlogic, Spire, some of these new space companies that you might have heard of, all commercial, all listed today. And I found this particular problem, the problem around friction associated with sourcing of Earth observation data, responsibly being the key word. So essentially, we see these three problems, and some of you may be able to relate to it, including the previous speakers, that you have access to satellites, if you do, that is, but then you're going to be reliant on limited number of satellites, right? So you might have your own sovereign satellites, you might have some contracts with some satellite operators, but that doesn't get you everywhere every time, right? So and then also with whatever the sensors you want, because you're not, I'm assuming, not a lot of countries I know that launch satellites with every possible sensor modality for Earth observations. Mostly people will do the users use either optical or SAR. So the inability to get data on time is one foundational problem. Even if you're initiated, like I said, you have some assets in space or you have some contracts. And imagine what it means for those who are not initiated, who actually don't use a space-based or satellite-based data, mostly using aerial and drone, because they put that acquisition of satellite data as in the hard basket, right? So the analogy I like to talk about is like you having your private vehicles, your own private vehicles parked in your driveway. And yes, you can use them when and where you want, but that is a limitation, because when those two vehicles are taken away, there is nothing else. So then you end up calling Uber. Or you might be in a place where your vehicles are not there with you. You end up calling Uber. That is a way of life you come to get used to. Or you cook at home and visitors rock up and you call Uber Foods because you can't bother to cook again. So this is all resource constraint model, and we are about unlocking that resource constraint. So that is the first part of the problem. The third part of the problem is affordability. If you want archive data, historical data, that's a solved problem. As you may know, there are lots of marketplaces that provide historical data from lots of operators. One thing I'll tell you upfront, we don't do that. That's not a problem we are solving. That's a solved problem. We are solving the problem. You have a situation unfolding in the next 1 hour, next 2 hours. You want to be getting the situational awareness of what's happening in the future, just like you call Grab. That is the problem. Now, that problem is typically solved only for defense. Why? Because they can spend millions of dollars to get access to lots of satellites or fly their own satellites. How about the 2% and their pet startup? How about that government agency? How about that very long tail users of Earth observation who need data in the next 1 or 2 hours, fresh data, but they just can't because they can't afford to spend hundreds of thousands and millions with different operators? That is the affordability problem. The third problem is the usability. You get all the data, how long it's going to take time to extract that information. There was a fantastic presentation from engineer about different use cases. I was very mesmerized just looking at the kind of work that is being done. Now imagine that work, all those use cases she showed, that doesn't take hours and days, but that happens in minutes. How do you convert these, not sensor spatial spectral data or a particular sensor, but how do you extract information through sensor fusion of different data sets? How do you do all of that within minutes and not hours and days, so that you actually improve the usability? As you know, information velocity is currency, right? So it's about how do you get that information in minutes? And so that is the usability problem. So these are the three big problems. So in the interest of time, from here on, I'm just going to go very quickly, and feel free to stop me or we can have a follow-up discussion. Essentially, what we did was to bring all the sensor modalities that's out there, imaging, non-imaging, all onto one platform, tasked through one workflow. Just like you can call Uber and you can call different kinds of Uber in different sort of requirements of yours, right? Small car, large car, shared car, etc., etc. Same concept. So we bring all the sensors out there, and we bring from both commercial and government. So we host a number of government satellites for direct tasking, as well as obviously lots of commercial satellites. Otherwise, we wouldn't be the largest satellite operator in the world without owning a single satellite. And you might have heard this phrase before many times, right? Airbnb, largest hotel operator in the world without owning a single room, Uber, and so on and so forth. So that's how we are. We are that aggregator for direct tasking. Direct tasking here being self-service. 2 o'clock in the morning, 10 o'clock in the morning, 6 o'clock in the evening, whatever time you want, you are able to task these satellites as if it's your own assets. That's the capability we provide. We provide that on subscription. So having solved that accessibility by bringing all these sensor modalities across so many satellites on one platform, we now make that available through subscription. That is how we solve the affordability problem. The affordability problem gets solved by it being only 5,000. Somebody's trying to say something, speak something. Anyway, there's a voice interference. Okay, so there is a subscription. This platform is available on subscription. It only takes $5,000 to get started. So that is the starting point. And if you are in the business of tasking satellites, you know, it's very hard to get even a $5,000 tasking. There are maybe 1 or 2 sensors out there. So this is the affordability problem solved, $5,000 for the entire year in credit to access these 475 plus satellites and the information we extract on the back of those satellites, which I'm going to talk about as a usability problem solved next. So just to give you an idea, so if you're wondering what are all these sensor modalities, what do they look like? It's like the Netflix of sensors, all the sensor modalities that you can possibly think of, you know, starting with multispectral, very high resolution of 30 centimeter, all the way to 5 meter, stereo, tri-stereo. May I request whoever is speaking to probably go on mute? It's just coming through very loudly on me. Anyway, if he or she is able to hear me say that. Okay.
Yeah.
Mahesh, I think it's you. Could you please mute, Mahesh?
No, it's not me. I was trying to find out who's.
Oh, you're trying to find out. Sorry. Okay, that's fine.
I think Mr. Ghassan, mic is, he forgot to mute it. Mr.
Okay.
Ghassan, I guess.
Right.
Yeah.
Appreciate it. Okay. Thank you. So let me just rock and roll. So this gives you all the sensor modalities, as you can see, right? I don't want to read it. I'm sure you can read it. So, you know, hyperspectral, we were the first to introduce hyperspectral for direct tasking. We were the first to introduce greenhouse gas, thermal, and obviously there are lots and lots of optical SAR. When I say optical, multispectral, SAR, video, greenhouse gas. So I saw somewhere about somebody asked a question in the chat about emissions, methane emission, CO2 emission. So we host a greenhouse gas sensors. And the beauty is, and then obviously lots of non-imaging sensors, right? AIS, RF, X-band, S-band radar, you know, VHF, UHF, L-band. So lots of different communication signals we pick up. The beauty is this is where the Uber Eats for satellites come in. Our ability to combine these sensors, any of these sensors or all of these sensors on the fly in a single task. It's a world's first capability. Same area of interest, time of interest. You can drop these sensors from different operators, regardless of commercial government, into the same task flow, just like you can order Uber Eats across multiple restaurants in the same order flow. So that is a very unique capability. Obviously, what that means is that engineer mentioned, it unlocks a lot more insights. It solves wicked problems. So we have customers combining, you know, thermal with multispectral, optical with SAR, greenhouse gas with multispectral, because you can get a plume, emission plume, but you don't have the context. You can't just put it on Google Earth Engine and expect to give you context. What if that information is 1 month old? So you task multispectral and greenhouse together. So things like that. Then you go into AIS, RF, you pick up all those signals. You can do tip and cue between them. Lots of maritime use cases, everything from drug smuggling, human smuggling, human trafficking, drug smuggling, illegal fishing, lots and dark vessel problem, lots and lots of those use cases are also solved by bringing those non-imaging AIS RF sensors together with imaging sensors. And then 3D and LiDAR from space is coming next year. So it just gives you an idea of all the different sensors. So we basically deliver this like an e-commerce experience. This is a very simple tasking capability across. We simplify this so that anybody can task. You don't need to be a PhD. And yeah, so you can task 1 or more satellites, just like you buy different things on the e-commerce platform of your choice. This is the best part. When you task, you can say, what are you tasking for? either information that is of interest to you or value-added product that's of interest to you. So you can say, I want to understand the deforestation. I want to count the number of trees. I want to see what has changed between my last month's road network and this month's road network. So that is what we call in information interest is, i.e. the feed. Or you could say, I want a DEM. Engineer was talking about DEM. We deliver DEM, DSM, DTM, digital terrain model, anything from 8 to 12 hours as part of the same workflow. So the same tasking workflow, you can request an information feed, or you can request for indices, you can request for value-added products. It gets delivered in the same workflow. And then we also let customers design their own tip and queue. So you may know tip and queue is a concept when you get two sensors to work together automatically, so there's no human in the loop. Just like Uber, transparent pricing, it'll tell you, like, I want to go A to B. You say, I'm going to task with this service level. Emergency service level will deliver the data within 6 hours. Tasking to delivery 6. Standard, the data will come after 1 day. So multiple temporal resolutions handled through service levels across all the different sensors. So obviously there is different pricing. So you are transparently told what is the cost of the task that you just put together, in what spatial, spectral, temporal that you wanted. And then essentially you lock it in based on the choices given to you, just like Uber will give you many choices. And then you receive the data on our platform. You can visualize lots of different visualizations, time series, comparisons, overlays, multi-sensor overlays, etc. And then, like I said, we deliver feeds, which is computer vision machine learning models applied on the fly. So it extracts the information from the task data and tell you where the transshipment is happening, where the vessels are, what kind of vessel it is, or any other object and feature extraction. We deliver flood maps on SAR within 2 to 3 minutes of the SAR data, the flood map will arrive. And you can also send the data to your target location. So automatically when you're tasking, you could say, I want the data to go to my target location. So we have defense customers who don't want the data on our platform. The data will go straight to their own command and control systems. Fully automated. So I'll skip in the interest of time very quickly. So all sorts of different use cases, as you can imagine, right, that this will get applied for change detection, object detection, feature extractions, etc., etc. Classification. This is a case study. This is one of our early defense clients case studies, but it applies to anybody who kind of fits our narrative, right? You have access to satellites, but they're always going to be limited. And that limitation brings about constraints. The constraints for this defense client was there was no certainty of acquisition, although they had contracts with 3 operators. They were not able to combine the data because they all coming in different platforms, collected at different times. They had no control over it. Then obviously all the sourcing friction, which you're familiar with, as you can read from the left side. And that's what on the right side we solve. We deliver yay or nay within few seconds to minutes, yay or nay within few minutes. So you can move on to some other operator, or you can hand over to the platform. You don't pick an operator. You say, I just want this outcome. Platform, you go figure out. So the platform automatically figures out and task the ones based on your requirements. So lots of different workflows, tasking flows. I'll come to that in a minute. Essentially, all the data is in one place, collected together, so you can combine, fuse, do a few fancy things. We are probably the only operator who can operate. We can collect optical and SAR round about the same time. We do what's called a synchronized tasking. As you know, there is not a single satellite where there's an optical and SAR payload together. But we do that, on the ground by sending commands to optical and SAR and bringing them close enough together in terms of capture collection times, so long as they are within half an hour. As you know, anything captured within 20 minutes is considered to be not changed. So we try to bring 2 sensors completely different together in the same workflow. We call it synchronized tasking. So things like that in capability. So this is basically the world's first standardized and simplified tasking across all the sensor modalities with these attributes. This is the part I mentioned where the usability problem is solved. So you task at the time of tasking, you say, what are you tasking for, right? And that can fall into object detection, classification, change detection, segmentation, whatever it might be. That is the underlying model, but it applies in the context of what are you doing it for, right? Are you looking to detect a vessel, illegal transshipment, or deforestation, the impact of deforestation in terms of loss of biomass? What is the construction change? What is the flood inundation? How many trees are in my plantation? Etc., etc., etc. These are all feeds. So essentially data gets delivered, and on the back of it, 2 to 3 minutes, the information feeds gets delivered as a GeoJSON. If you requested for a elevation product, like a value-added product, which we call elevation products, and indices, we call them value-added products. That takes indices come together with the data at the same time on the fly, whether it's NDVI, NDRE, all the different indices. There's a number of indices we are releasing based on the hyperspectral sensors on the platform, but also elevation products, DSM, DTM, they all come between 6 to 8, 10 hours, depending on the sensor type, resolutions, and so forth. Tip and queue, automated tip and queue, where you get two sensors to work together. You can construct your own tip and queue based on your context. This is just showing it in the maritime context. So this brings home the value of our platform. Remember, I said everything is about information velocity. That is currency. So if you are trying to solve an illegal transshipment or a dark vessel problem, and you can see this in any context, land use context, when you need to bring multi-sources together, coming from multiple sources, multiple operators, multiple times, there is a huge time lag. As you know, if you are using multi-sensor to solve your problems, this is the foundational value of our platform. We are the world's only multi-sensor platform. So imagine when you bring all these different sensors together, when you task them together either as a single task or you sequence them. Even when you sequence them, it's the same single task, because the second task or third task happen only when the first task is completed. Whether you combine task them or sequence task them, you get to the outcomes you want, the use cases you want to solve, the wicked ones. It's done faster and better and cheaper on our platform. These are the 6 reasons. So you might be familiar with marketplaces. There are several marketplaces. One of them got sold to Saudi PIF fund yesterday. You all might have picked up, right? One of Saudi's funds picked up one of the marketplaces out of Germany, founded in 2019. We are not a marketplace, right? So the marketplaces solve different problems. Like to begin with, like I said, we don't do archives. So, all marketplaces start with archives. We didn't even bother about archive. We are solving the responsive access problem. So these are the 6 reasons why we are different. I realize I'm over time, so I'm not going to read them, but I'm sure you can read them, speed read them. So these are the 6 reasons. So particularly if you are an equatorial belt, you get the maximum coverage and revisit on your platform. Why? Because we have satellites in every orbit. Polar, mid-incline, and near equatorial. Who goes to near equatorial? Not commercial, governments. So because I said our partnership with several governments, we have satellites from every orbit, increasing the revisits in the equatorial. In the equatorial belt, we do something like in optical 6 to sometimes 7, 8 times a day, and SAR twice as much. So practically every 90 minutes, you can get a SAR coverage over equatorial belt. When I say near equatorial, plus or minus 15 degrees. Embeddable. So our platform gets embedded into third parties. So we have defense clients who embed us as a live tasking information capability into their C2, command and control. So we do that as well, in addition to other things. So I was listening to engineer's presentation and I said, this is our general pitch. So this is my last slide. We look at bringing this capability not as a replacement, but as an augmentation to the nation states and space agencies we work with. So our number 1 customer segment is defense, number 2 is space agencies. And so we work with a number of space agencies. Some of them have assets in space, some of them don't do. When they have assets in space, we augment them. When they don't do, we become the natural, fast start, jump start, fast start, capacity capability provider, because, you may have 2, 3, 5, 6 satellites. Augmenting with 475, 500, 600 satellites, you get a resilient Earth observation, a situational awareness platform. Thank you very much. So that, in conclusion, is who we are. Sorry, I spoke fast.
Thank you, Shankar. I know you had a very less time, but
well, I still went over time. Sorry about that. I realized I spent 16 minutes.
No problem. So actually, we are very proud to be associated with you in this region. In fact, for the audience, I'd like to say that Microcenter is a channel partner for iSpace in Bahrain, Saudi Arabia, Kuwait, and Qatar. So with this, I would like to ask the audience to come up with your queries. So since Shankar would be here for some time.
I
Any
think everybody's
queries?
looking. I think everybody's looking for their corporate credit card to sign up with $5,000. They're all going to get their corporate credit cards.
And if you want more information about Earth iSpace, you can always get in touch with us. You can email us or write to us, and feel free to ask your queries. Yeah. So with this, I will move on to the next topic. The next speaker for the day is Mr. Aduri Srinivas. He's a senior person in Micro Center. He heads the strategic projects for Micro Center, and he's been doing some lovely job this year, and we've been winning some really good projects. So the topic for Mr. Aduri is from data to development, AI in urban analytics. With this, I would hand over the screen to Mr. Aduri.
Thank you very much, Mahesh. Good morning. I'm Madhuri Srinivas from Micro Center, working as a statistics project head. And I'm excited to talk about AI in urban analytics with you over the next 45 minutes. So my topic about from data to development, AI in urban analytics. Now the topic starts from an overview of urban planning and urban analytics. And I'll also talk about key data components in urban analytics. And I would like to talk about an overview on artificial intelligence, machine learning and deep learning and generative AI. And I'm also interested to talk about on algorithms, how we can fit into these algorithms in urban analytics using deep learning and ML. And there are certain key components to design AI-powered urban frameworks. And I'm also going to cover on AI urban analytics and what is the role of RGS Enterprise and how do you integrate AI models into RGS platform. So I'll talk about on a comprehensive workflow. And I also discuss about on conceptual architecture about integration of AI and E3 RGS platform. And I'll explain about AI and RGS web application components and solution overview. And what are the AI and GIS tools that comes under urban analytics. And I'm also interested to talk about on GeoAI, how we can apply the artificial intelligence into the geospatial data. And finally, I'll close with my last topic on key steps on AI-based urban planning. Okay, urban planning. Before go to the urban analytics, I would like to talk about on urban planning. Urban planning is the process of managing and organizing urban spaces for efficient and sustainable development. It includes planning roads, housing, public services, and infrastructure while regulating land use and building rules. So urban planning includes long-term strategies such as creating master plans for urban growth and daily operations like zoning and building permit management. Now, urban analytics applies data-driven methods and analytical techniques to study urban systems. So it involves collecting, processing, and analyzing data to understand urban phenomena like population trends, land use distribution, and even transportation systems and environmental impacts. So urban analytics uses advanced data analysis to address urban challenges by combining the big data, GIS, AI, and machine learning, and even predictive models. It helps and analyze and improves the systems in urban areas such as housing, infrastructure, and even public services. Now, what are the key data components in urban analytics? So it includes data from various sources like geospatial data, So geospatial data provides, as you know, that it provides to accurate location-based information, enabling the visualization and analysis of spatial patterns, relationships, and trends in the urban planning. Now, demographic data component is also very, very important in urban analytics because it helps to understand the population distribution, age groups, income levels, and other socioeconomic factors for targeted planning. Now, coming to the infrastructure data, it provides an information on utilities, okay, roads, and even public transportation and buildings, enabling the evaluation of current capacity and the planning of future developments. Now, economic data is also an important component in analytics, and it assists in analyzing market trends, employment rates, and resource allocation for sustainable economic growth. Coming to the environmental data, it tracks natural resources, climate conditions, and ecological health, ensuring sustainability in urban development. Of course, historical data is also very important in urban analytics because it understands the past trends in urban growth, infrastructure usage, and policy impacts. For example, historical land use and population trends, and you can transportation usage patterns, etc. Land use and land zoning data, which evaluates and manages how land is allocated for residential, commercial, and including industrial and recreation purpose. For example, zoning maps, building permits, and land parcel data. And I'm interested to talk about brief on AI, ML, and deep learning and generative AI. It's an overview. So coming to the artificial intelligence is a technology that allows machines to learn, think, and make decisions to solve problems. So applications of AI, predictive analytics. Predictive analytics basically in AI, forecasting urban growth, traffic patterns, housing demand. Now coming to the image recognition, like land use and land cover analysis, identifying and classifying land use patterns such as residential, commercial, and green spaces using satellite imagery or aerial imagery photography. Now, infrastructure monitoring, detecting changes in the buildings, roads, or even public facilities to access development progress. Now, what is the role of NLP in AI, especially for public sentiment analysis? So, analyzing the social media posts, surveys, or even public comments to understand community options, opinions, not options, I'm sorry, community opinions on urban projects or even policies. Now, the machine learning also is a branch of AI that enables computers to analyze the data, identifying the patterns, and improve their performance on tasks through experiences without explicit programming. Like applications, urban growth prediction, meaning, for example, urban growth prediction, that is to predict urban growth over the next decade and plan infrastructure or even housing and public services effectively. And also applications like image recognition, recommendation systems, fraud detection, and even predictive maintenance. Now, what about the deep learning? It's a type of machine learning that uses a layered algorithm called neural networks to analyze large amount of data. It's especially good at tasks like recognizing the images, understand speech, and making predictions. So again, deep learning is a subset of machine learning that focuses on using deep neural networks, which have many layers, like a deep. So if you look at this picture, like this is a typical picture of deep learning neural networks. It shows input layer. It receives the data, for example, images and text. Now the hidden layers. These are multiple layers where computations are performed using neurons like nodes to learn features and patterns from the data. Now coming to the output layer, produces the final prediction or decisions based on the learned patterns. So this is a core concept in deep learning, which uses these layers to model complex patterns in large data sets. And widely used applications like image recognition, for example, object detections, facial recognition, and coming to the speech processing, for example, voice recognition, text to speech, etc. Now, generative AI. Generative AI uses advanced algorithms that leverage the machine learning and deep learning to automate the design, optimize layouts, and contribute to sustainable and urban development. So the most commonly used algorithms is a GAN. GAN is a type of machine learning model specifically within the subset of deep learning. So what GAN does? It is used for generating realistic, designs and layouts and urban models by learning from existing data. For example, you can take optimizing building layouts. And there is also another, generative AI models like, VAE called variational autoencoders. It's very important model, especially for generating new designs based on learning patterns and in urban planning data sets. For example, proposing an alternate zoning configurations or infrastructure designs, variational autoencoders. Now, I'm interested on this slide, especially what algorithms may fit into the urban analytics. I would like to talk about convolutional neural networks, especially CNN. CNN or deep learning models are designed to work with images. Of course, convolutional refers to as a mathematical operations used in CNN to process the data. So in CNN, layers are the building blocks of the networks that process and transform the input data on step by step. So each layer has a specific role. So convolutional layer, extract features like edges, shapes, or even textures from input data, for example, an image, and applying filters. Now pulling layers, it reduces the size of the data. That's called a feature map, while retaining essential information, making the network more efficient and reducing the computation. Now fully connected layer, again, it combines all extracted features and make the final decision, such as classifying the image and the image into the specific categories. So this is a simple CNN architecture. Now coming to the support vector machine, is a machine learning algorithm used to classify the data, predict outcomes, and identify unusual patterns. It works by finding the best boundary to separate different groups and performs well with both simple and complex data. Now, it's a graphical representation here, how a support vector machine algorithm works. Now, there are two classes here, class 1 and class 2. So the data points belongs to the two groups or classes marked as class 1 is on red and second one is a blue as a class 2. Okay, so the classes, the data points belongs to two group classes here, as I explained. So coming to the decision boundary, the decision boundary, it represents the the yellow line represents the best boundary that separates us two classes. Okay, coming to the sector support vectors, the highlighted points circled in purple are the closest points to the decision boundary. So this is the decision boundary, it's yellow color. So these are collected as a support vectors and they help define the boundary. Now, how the support vectors? So support vectors will help define the optional boundary that separates the group. For example, regions with different income levels in urban analytics. Now, what are the key components of designing AI-powered urban frameworks? We'll discuss in a brief. So coming to the data collection, data preparation management, I'll go one by one. So the data collection as a key components in designing AI powered urban frameworks, data collection, we can gather gathering the spatial and non-spatial data sets from example like maps, land use layers, demographic 3D models, real-time feeds, etc. So the data preparation management, we need to have the pre-process, and we can use stored data using ArcSD for a spatial data engine, as well as in PostgreSQL to store the data, especially for urban analytic frameworks, and ensure the interpermeability with the GIS tools and AI systems. Now, what is the role of AI development as a key component? We need to train machine learning models for tasks and for land use predictions, for example, even traffic forecasting or even population. And we need to use advanced deep learning techniques for spatial and temporal analytics. And we can also use geo AI and deep learning techniques to handle complex urban data sets. Now, real-time utilization. Process the real-time data feeds, for example, traffic, weather, air quality, or even environmental metrics to enable dynamic decisions and real-time monitoring of visualization and develop the GIS dashboards. And when we go for development of the AI and GIS development, we can build interactive tools and dashboards for urban planners for decision making. And we can also incorporate in geospatial visualizations and develop any AI-driven insights. Now, the deployment scaling is also important because to host applications on a cloud platforms, especially for scalability. And during the deployment scaling, you need to integrate how the urban systems for operational analytics and deployment. And continuous learning and optimization is also important because to keep on updating the AI models and GIS workflows regularly with the new data. And public feedback is also very important from the users and the system performance to refine and enhancing the enhancements of the solutions. Now, stakeholders engagement is also very important in the urban frameworks because to identify and involve urban planners, policymakers, and community stakeholders, and they need to align with the system in the real world needs. Data governance and security coming to that, it's a protocol, of course, for the data privacy and access control and compliances with the, like GDPR and even data sharing and policies. Now, performance and monitoring and feedback mechanisms and capacity building and training is also important to train the stakeholders and end-to-end understand the GIS tools, how AI Analytics has developed, and what is the development of the application interface. As a capacity building and training is also very important under the part of urban frameworks. Now, AI in urban analytics, what is the role of RGS enterprise? And we are aware that RGS Enterprise is useful for developing AI applications in urban planning and urban analytics because it provides a powerful tools to manage and analyze, visualize the data. And there are advantages. It includes like central data management. So central data management stores and organizes large amount of spatial and non-spatial data, making it easier to access and use for the AI models. Now, advanced spatial analysis offers to build on tools for mapping and spatial analysis and data visualization, and it helps to uncover patterns and urban trends in the urban areas. Coming to the integration with AI, RGS Enterprise can connect with the AI tools and frameworks, allowing you to apply machine learning and deep learning techniques to geospatial data. Now, the real data processing, it supports, of course, the live data feeds such as the traffic or even weather, or enabling real-time analytics for urban decision making. Scalability and collaboration. It allows multiple users to collaborate on urban planning projects, and it can also scale to handle, complex data and workflows. Now, the integration of AI and ArcGIS. Okay, this is the core components. This is the core components in the integration of AI and ArcGIS. Now, AI in urban analytics application, this is the central system where AI power tools and analyze and optimize urban data for better decision making and urban planning and resource management. Now, what is the role of ML engine here? Machine learning, ML engine is a framework, a system that enables the development, training, deployment, and management of machine learning models. It serves as an engine that drives AI capabilities by processing data or even applying algorithms and delivering the insights from machine learning models. Now, RGS Enterprise, it's a platform that enables the management of visualization, analysis of geospatial data, and it can be integrated with other components to support urban analytics and deliver the spatial insights. Now, coming to the data inputs, PostgreSQL is very important here because as a database for storing and managing the geospatial data, of course, it also serves as a backend to efficiently handle large data sets such as maps or even land use data or even infrastructure details as such. Now, the data inputs, for example, for urban analytics can go for demographic data, or climate, or even economic data, or even land use, land zoning information, or even what do you call that, traffic related and mobility data and transportation data, vice versa. These are all the data inputs. Now, for example, demographic data, what it does, it gives the data inputs are important. For example, population density is, in terms of an income levels and other social matrices. And importantly, the land use and zoning information is very important. It gives the details about land allocation for residential, commercial, industrial, and recreational, uses. And supporting features, of course, it's very important to develop an digital twin platform integrating with the AI and GIS, integration of OpenBIM. I'm not talking about the closed BIM. Integration of OpenBIM and 3D building models and LiDAR data can be integrated. The advantage is that enabling detailed visualization and planning by incorporating building information modeling with the 3D scans and even LiDAR data. And coming to the integration of real time and the data feeds, okay, we can get it from even IoT sensors or with traffic systems or even environmental monitors for dynamic analytics pattern. Meteorological data, I mean, this is weather related, data for climate analysis and planning. So this is the core components of integrating AI and RGS conceptual architecture point of view. This is general overview, like data collection, AI and RGS and urban analytics systems, and base maps, of course, and what are the data inputs are required, land use and demographic, meteorological, and real-time data. Now, RGS and web application components, this is a simple architecture. It integrates AI and RGS for a web-enabled web-based urban analytics application. The front-end application here I'm showing JavaScript API and React.js, of course, Bootstrap for interactive geospatial visualizations and a responsive UI. And the backend here, I'm talking about the .NET Core, and you can use RESTful APIs and connects to the PostgreSQL spatial database for geospatial data management, and ML engine for example, any predictive analytics. So therefore, RGS Enterprise facilitates geospatial operations and integrates real-time data feeds for dynamic urban insights. Now, AI and GIS tools for urban analytics. I'll talk about a little bit about what are the tools that we can develop. For example, like if you go for interactive GIS maps, excuse me. An interactive GIS map, it enables users to view, manipulate, and interact with the various GIS layers such as land use, zoning, and infrastructure in real time. And we can integrate with the satellite imagery or even RGS online for detailed and accurate base maps, providing a seamless geospatial experiences. Now coming to the layer management, it allows users to toggle, like a different layers. For example, transportation, zoning, 3D buildings, and need to upload any custom GIS layers and integrate the GIS data. So what is the data? Like, zoning plans, land use maps, or even BIM models for predictive spatial analysis. So under layers management, it also supports interacting with the AI and generated results from many enhanced decision making. Now, AI-powered analysis. AI-powered analysis enables users to run deep learning models for tasks like land use predictions and traffic simulations directly on the map. Generative AI tools can create and optimize the building layouts or zoning plans based on input and constraints. Now, 3D visualization also important to integrate 3D city models for any real-time visualization of urban designs, massings, even building layouts. We can also use WebGL libraries like GIS. It's an open source because it's for 3D rendering. We can use open source JavaScript libraries like GIS. So therefore, users can seamlessly view AI-generated massing models directly on the map for enhanced spatial insights. Zoning and urban planning tools. It helps to develop and edit and even viewing zoning regulations such as height limits and density restrictions, or even AI-generated recommendations such as an optimal zoning changes to support sustainability and even economic growth and objectives. Real-time data analytics and dashboard. It offers a live data display of urban metrics such as traffic flow or even pollution or even energy usage and pollution density. Therefore, integrate the real-time data feeds from sources like CCTV or even IoT sensors for dynamic city monitoring. Report generation. It enables users to create and export detailed reports on AI analysis, zoning proposals, and even simulation results, providing an actionable insights and visualizations for stakeholder presentations and decision making. Now, finally, the digital twin solution enables real-time simulation of urban planning scenarios such as housing development, climate change adaptations, or even traffic analysis, providing a dynamic tool for informed decision making. Now, GeoAI. I'll talk about the GeoAI, how it can apply the AI in geospatial data using E3 component tool. So GeoAI is combines with an artificial intelligence with geospatial data tools to solve spatial problems. It uses AI methods like extraction, classification, and detection to process structured or even unstructured data, generating valuable spatial insights. Of course, we can implement deep learning by fine-tuning pre-trained model, or we can create the custom models. Therefore, RGS integrates with the deep learning frameworks to analyze images or even point clouds or even other spatial data sets, enhancing geospatial workflow efficiently. So therefore, to implement deep learning in your workflow, you can use fine-tune pre-trained deep learning packages or train your own deep learning models. Now I would like to talk about integrating AI models into RGS platform as a comprehensive workflow. Let's take step 1, data preparation. Use GIS data, example, land use maps, population density, or zoning data, to prepare the data sets need to be for training AI models. Now, what is the purpose? Ensure that the input data is a clean, well-structured, and ready for machine learning tasks. Now, coming to the step 2, step 2 for the model selection. We can choose an appropriate AI models based on the tasks. For example, CNN, convolutional neural networks for land use classification or change detections. Then what is the purpose? Tailors the AI model to meet the specific requirements of GIS application. Now the step 3, model training. Train AI models using data from ArcGIS and other sources like satellite imagery or even demographic data sets. What are the tools? Frameworks like PyTorch or even GA are utilized for training. Now, what is the purpose? It creates a trained model capable of making accurate predictions. Now, coming to the step 4, export the model predictions to GIS format. Now, once you finish, then you can convert AI model outputs, for example, land use classifications or predictions, into GIS compatibility formats like GeoJSON or even shapefile. Now, the tools like an ArcGIS API for Python, like ArcPy, can be used tools for exporting the tools predictions to the GIS format. Now, what is the purpose? Ensures the AI generated results can be directly used into the GIS systems. Now, how to integrate the components in step 5? Integrate AI results into the ArcGIS. Now we can upload AI outputs as a feature layers into the ArcGIS enterprise and hosting layers, for example, land use predictions on ArcGIS Online or an enterprise for visualization and analysis. We can use ArcGIS API for Python, or you can publish ArcGIS server REST services. Now, what is the purpose? Allow the AI models results to be generated or integrated and utilized within the GIS workflow for further analysis or decision making. Now, this is my last slide. I'm talking about on key steps like problem definition and goal setting. So under AI-based urban planning key steps, problem define and goal setting, meaning define the challenges and desired outcomes. For example, how we can optimize land use to balance residential, commercial, and green spaces with ensuring sustainability city growth. Now, data collection and preparation. Gather, organize, and pre-process data such as a traffic flow, road layouts, and population distribution. Model building and training. Use the prepared data to create and train AI models designed to analyze urban systems and assist for urban planning and management decisions. Scenario simulation and optimization. We need to evaluate different scenarios such as impact of new housing and development on public services. Now, coming to the decision making and policy support, leverage the data from urban analytics to support planning decisions and policy development for urban areas, and implementation and monitoring. Put the solution into the action, like a new zoning plan or infrastructure improvement, and monitor its performance over the time to ensure it achieves the goals and adapts to changing urban needs. Now, feature expansion and scaling. Adapt and enhance urban planning solutions to address and changes needs for infrastructure, future development, and goals. So this is a workflow to streamline an integration of AI and into the GIS, enabling tasks for land use planning, urban analysis, and predictive modeling. So thank you very much. And I completed my presentation today.
Thank you, Mr. Azari, for throwing light on AI to Geo AI to urban analytics.
Thank you so much.
Thank you so much.
Thank you. Yeah.
Actually, the floor is open for queries. If you guys, feel free to ask queries. So we have a query from Fatih Issa Burshid. Can you please speak out? Yeah.
Sure. Thank you so much.
Thank you, Mr. Fatih. Yeah.
Thank you. Actually, thank you, Mr. Adori. My question is directed to Mr. Shankar earlier. Thank you for the presentation and also for answering the queries in the chat box. I have one more inquiry actually. Is there like a minimum number of months for the commitment? For the commitment for the subscription service. So it can be like, yeah.
This is the friction I talked about, right? Removing the sourcing friction. So absolutely, I mean, if you go to any satellite operator, they talk about lots of commitments and minimum spend dollars and time periods, nothing. Very simple. $5,000 gets you access to the platform, turns automatically into credit, just like Uber Pay, Uber Money, sits in your wallet. You can task it for all the way up to 12 months. It's an annual
I see.
subscription. So your 5,000 lasts for 12 months. So even if you finish your first 5,000 in 1 week, you still have access to the platform for 51 weeks. And then you can pay as you task. You can pay $200 tasking or $2,000 tasking on demand.
Okay, so now the credit that you said, it will be related also to the size of the imagery, the type of imagery, if it is a
No,
multispectral or if it's yes.
Just like Uber, you will have different pricing depending on how far you are going, what vessel, what vehicle type you want. Exactly same concept. So obviously, if you are going to ask for 25 centimeter SAR and you want it in the next 4 hours, that's going to cost you a lot more. You want 1 meter SAR and you're happy to get it after 1 day. So it's completely up to you in terms of what your requirement. The beauty is the platform will generate the pricing on the fly in real time. So as you put through your task, just like Uber, it'll automatically generate your pricing and it'll give you multiple options. And it's up to you which one you want to confirm. And that gets locked in.
Okay.
And it deducts from your first $5,000. Sorry, please.
I see. Yeah, thanks. I take it also you are providing archived imagery also?
No, that's what I said repeatedly. So we are a responsive acquisition platform. We don't look back into history. So our customers on our platform, they build their own time machines. So we have customers who started 1 year ago, 18 months ago when we came to the market. They have built their own archive on our platform. But if you join today, you can't expect data from yesterday. You can start building your data set from today.
Okay. One more question. I'm just curious about the 10 centimeter imagery that you mentioned here in the chat box. So it's a satellite sensor or it's like aerial?
It's from Velio. So today, all our 475, 500 satellites and more coming. So by next year, we'll have 650, 700 satellites. But they're all on LEO, low Earth orbit, as you know, 400 kilometers and above. The Velio is the first 10 centimeter we will have next year is from very low Earth orbit, and that's between 150 to 200 kilometers.
And what would be? It's like a multispectral sensor, I believe?
It is a multispectral. So first one will be RGB, 3 bands. Subsequent ones will be 4 to 5 bands.
So it will be like in the near infrared range?
Subsequent ones, correct.
Yeah.
4 bands will include NIR and also other red, blue, green, other red, blue bands going into 5, 6 bands. But initially, it will just be RGB.
Well, thank you so much. Brilliant. Thank you.
Thank you. Mahesh, you are speaking to mute.
Yes. We have another query from Mr. Selvaraj Krishnan. Mr. Selvaraj, would you like to ask the question? Okay, the query says, I think it's for Mr. Aduri. Where is it?
I'm here.
Yeah.
Okay.
Yeah, what is ML Engine Urban Analytics using GeoAI? I think you actually explained this in your presentation. You want to put it short to him in short words?
Sorry, I didn't get that.
Yeah. There is a question. I think it was covered in the presentation. Probably he missed it out. It says, what is ML Engine Urban Analytics using GeoAI? Thank you very much.
Urban Analytics.
Anyway.
No, I didn't get that question.
I think if I interpret that somebody was asking what is the ML engine you're using in the GeoAI context, right? You talked about urban analytics, GeoAI. What is the ML engine you're using? Is it on AWS? It is some TensorFlow. What is the engine? Yeah,
we can use any ML engine. For example, when I talked about maybe you can use RGS platforms also. We can use for an ML engine. It basically generates the model. You can retrain the model. So basically, like you have to, as explained in my data in my previous slides, it's a process. Like for example, from the data preparation, model selection, model training, and export model predictions into the GIS format. So entire this workflow comes under as a part of ML engine. It does. So from the data preparation till exporting the model into the GIS format. So therefore, you can use any PyTorch, or we can use even GeoAI also for processing, as an ML engine components.
Okay. Thank you, Mr. Aduri. I think it's already we're running out of time.
Yeah.
And but before we finish that, I really want to show a mark of appreciation from Micro Center for all the speakers today. This is actually now it's in mirror mode, I guess. So it's The Power of Where by Jack Dangermond, Esri, and the GIS community. So we will send the book to your offices, and happy reading. So with this, I think we will wind up this great day. And but before that, we would like to take a picture. If everybody can come on video, Gigi is waiting to take a picture of us. Any more? Ms. Jauhar, would you like to come on screen? Choose it. Engineer Swad. Okay, I think we will take a picture. Others, why don't you come from the video? Mohib? Okay. Yes.
Thank you.